어린이 쓰거든. 아무에 있는 쓰거든. 아무에 있는 놈이 please 아무에 please 아무에 있는 나오. 아무에 아무에요. Hey Adi, how are you? What is TNT? Oh, it's a bomb. I don't play games. Good morning, Shiva. Wait, I have to time out this person. Whoever is this person? Who is it? I don't know who is this person, but I have to time out this person. I did. Shiva, I'm from Sikkim. By the way, where are you from? Is it morning there? Yep, it is morning here. This is also India. Please. Let's study, okay? I'll set for 60 minutes. Yep. We'll study for 60 minutes. I'm from HK. What is HK? Hong Kong. Oh my gosh, it's night right now. Wow. Study now, okay? Nice jacket. By the way, this is called hoodie, not jacket. Jacket is different. But thank you so much, Ari. America. No. Hello. Something. Yeah, young. Now let's study. Let's study. Don't text. Don't text. Don't text. Let's study, everyone. Motion. Free fall. Let us try to understand the meaning of free fall by performing this activity. Take a stone, throw it upward, it reaches a certain height, and then it starts falling down. We have learned that the earth attracts objects towards it. This is due to the gravitational force. Whenever object falls towards the earth under this force alone, we see that the object are in free fall. I am from India, Sikkim. Can I show? I learned so many things. You can't just like comprehend it. I'm teaching gravitation for class 9. I'm teaching electricity for class 10, and then I am doing one more chapter, that is chemical equation for class 10. And then from my side also I'm doing gravitation, current, electricity, electrostats, and then what else? I'm studying a lot of things at the same time. So we can't comprehend like what I'm studying in particular. I'm revising the modern physics also, so a lot of chaos is there. But right now I'm studying free fall. It's part of gravitation. Where's another force? Another forces. Forces applied. No other forces applied in this. Note, no other forces applied in this. No other forces applied in this. Force is applicable. Example. Force. Whenever objects fall. Thank you, Pug. You too have a great day. The forces applied in this phenomenon only gravitational forces are given. Example, falling of rock. We have learned that the Earth attracts objects towards it. This is due to the gravitational force. When object falls towards the Earth under this force alone, under this hmm, we say that the object is in free fall. Is there any change in velocity of falling object? Yes. Yes. An object initial velocity when object falls down, the initial velocity is whenever object falls towards the earth under this alone, we say that the object are in free fall. Is there any change in the velocity of falling object? While falling, there is no change in direction of motion of object. Yes. Changes. Change. When object falls down, their initial velocity is when object falls down, the initial velocity is 0. 0. As they falls down, their velocity changes and attains maximum velocity before reaching the ground, before RAAC reaching the ground, they attain the maximum velocity. While falling, there is no change in the direction of the motion of the object, but due to the Earth's attraction, there is a change in the magnitude of the velocity. But as the falls down, the velocity changes and attains maximum velocity before reaching the ground. While falling, there is no change in the direction of the motion of the object, but due to the Earth's attraction, there will be change in the magnitude of the velocity. Hold on. The velocity changes and attains maximum velocity reaching the before reaching the ground. Astaghfirullah. The Earth's attraction, there will be change in the magnitude of the velocity. Okay, change in the magnitude of the velocity. While falling, there is no change in the direction of the motion of the object, but due to the Earth's attraction, there will be a change in the magnitude of the velocity. Any change in velocity involves acceleration. Any change in velocity, mc square. Somebody is a fan of Einstein. He wrote E equals to mc square. But due to the Earth's attraction, there will be a change in the magnitude of the velocity. Any change in velocity involves whenever an object falls towards the Earth, an acceleration is called. When object falls down, their initial velocity is when object falls down, the initial velocity u equals to 0. But as they fall down, the velocity changes and attains maximum, reaching the ground. The direction of motion doesn't change, change, but the direction of motion does not change, but the direction of motion does not change. The direction of the motion does not change, but the magnitude changes. Changes. Magnitude of velocity changes. Change in velocity in okay. No change in the direction of the motion of the object, but due to the Earth's attraction, there will be change in the magnitude of the velocity. Velocity due to the attraction of the Earth. Of the Earth. Earth. Due to the attraction of the Earth. Okay. Any change in velocity? Okay. Change in velocity involves acceleration. Any change in velocity involves acceleration. Whenever an object falls towards the earth, an acceleration is involved. This acceleration is due to Earth's gravitational force. Therefore, this acceleration is called acceleration due to gravity. Due to the gravitational force of the earth, or acceleration due to gravity, it is denoted by g. The unit of g is the same as that of acceleration, that is meter per second square. Any change in velocity involves acceleration. Whenever an object falls towards the earth, an acceleration is involved. This acceleration is due to Earth's gravitational force. Therefore, this is called acceleration. Therefore, this acceleration is called acceleration due to gravitational force of the earth. Hi Rajiv. Any change in velocity involve acceleration. Okay. Change in velocity involves acceleration. Change in velocity involves acceleration. Change in velocity involves acceleration. This acceleration is due to the gravitational gravitational pull. This acceleration is due to Earth's gravitational force. This is due to gravitational pull of Earth. Gravitational pull of Earth. Change in velocity involves acceleration. This acceleration is due to the gravitational pull of the Earth. Gravitational pull of the Earth. Any change in velocity involves acceleration. Whenever an object falls towards the Earth, an acceleration is involved. This acceleration is due to Earth's gravitational force. Therefore, the acceleration is called acceleration due to gravity. Change in velocity involves acceleration. This acceleration is due to gravitational pull of Earth. Therefore, it is also known as acceleration due to gravity, or acceleration due to gravitational force of the earth, or acceleration due to gravitational force of earth. Acceleration due to gravitational force of earth, or acceleration due to gravity. It is denoted by g meter per second square. Acceleration due to gravity denoted by g meter per second square, same as that of acceleration. We know from the second law of motion that force is the product of mass and acceleration. F equals to me. That the second, no, from the second law of motion, force is the product of me. Second law of motion. Second law of motion gives force equals to mass into acceleration. Okay, force is the product of mass and acceleration. Let the mass of the stone is in activity 10.2 b m. Let the mass of the stone in activity 10.2 mass of the stone in activity 10.2 b m. We already know that the acceleration involved in falling object due to we already know that there is acceleration involved in falling objects due to the gravitational force and is denoted by g. The mass of the stone, and we already know that there is acceleration involved in falling object due to Rishabh, I'm not preparing for any exam. I'm preparing for my class right now. Good morning, Shubham. We already know that there is acceleration involved in falling object due to gravitational force and is denoted by g. We already know that there is acceleration involved in falling object due to gravitational force and is denoted by g. Therefore, the magnitude of the gravitational force F will be equal to the product of mass and acceleration. There is acceleration involved in falling object due to the gravitational force and is denoted by g. Therefore, the magnitude of the gravitational force F will be equal to the product of. Therefore, the magnitude of the gravitational force will be equal to the product of mass and acceleration due to gravitational force. That is F equals to mg. G equals to capital G. Small g is equals to universal gravitational constant mass of the earth upon distance square or radius square. G equals to capital G, universal gravitational constant mass of earth upon d square, where m is the mass of earth and d is the distance between object and the earth. Mass of the earth, mass of the earth, distance, d is the distance between object and the earth. D is distance between object and the earth. Okay, g equals to capital G, capital M upon d square, where d is the distance between earth and object, distance between earth and object, distance between, it is the distance between earth and object. M is the mass of earth. Let an object be on a near surface of a earth. Let an object be on the near surface of the earth. The distance d in equation 10.7 will be equal to r, the radius of the earth. Okay, the distance d. Okay, let an object be on the near surface of the earth. The distance d will be equal to r, the radius of the earth. Thus, for objects on or near the surface of the earth, g equals to capital G m upon r square, radius of the earth. D is will be equal to r, the radius of the earth. Thus, for object on or near the surface of the earth, g mg equals to g m into capital M into small m upon r square. The earth is not a perfect sphere, as the radius of the earth increases from the poles to the equator. Hey yo, what the heck? The earth is not a perfect sphere, as the radius of the earth increases from poles to the equator. The value of g becomes greater at the poles. Okay, पोलमा पोल्स POLS पोल्समा जी इन्क्रिज हुन्छ पोलमा के हुन्छ जी इन्क्रिज हुन्छ रेडियस डिक्रिज हुन्छ रेडियस डिक्रिज भएर जी इन्क्रिज हुन्छ के एट इक्वेटर जी डिक्रिज हुन्छ किनकि रेडियस इन्क्रिज हुँदैछ रेडियस इन्क्रिज हुँदैछ जी के हुँदैछ घट्दैछ रेडियस इन्क्रिज जी डिक्रिजेस greater at pole than at equator. For most calculation, we take g to be more or less constant on or near the earth. Landing of plane is not an example of free fall. Landing of plane or hot air balloon is not an example of free fall. Free fall. Rolling of a stone is free fall. What else is there? Friction force is there, no? Rolling ma drop exactly drop. Paper, paper, paper. Free fall. Air resistance is there. Resistance is there. फ्री फलमा के हुन्छ होइन त अब्जेक्ट गिर्नुपर्छ एउटा सर्टेन हाइट अटेन गरेर तल झर्छ सोल फल के हुन्छ ग्राभिटेसनल फोर्स मात्रै लागेको हुनुपर्छ यसलाई के भन्छ फ्री फल भन्छ पेपर जुन चाहिँ गिर्दैछ एयर रेजिस्टेन्स छ त्यो होइन इन्जिन होइन ल्यान्डिङ अफ एरोप्लेन पनि होइन फ्री फल हट एयर बलुन पनि सो इक्जाम्पल होइन फलिङ अफ पेन हो फलिङ अफ बल हो दुईवटा अब्जेक्ट जसको मास हेभी हेभी छ कुन चाहिँ फर्स्ट झर्छ दुइटै बराबर टाइममा झर्छ कि मास डिपेन्डेन्ट छैन भन्छ अब्जेक्टमा डिपेन्ड गरिदिएको छैन अर्थको मास हो यो अब्जेक्टको मासमा डिपेन्ड गर्दैन डिस्टेन्स स्क्वायर भनेको अब्जेक्ट र यसको बिचको डिस्टेन्समा डिपेन्ड गर्छ अप्रोक्सिमेटली सेमै हुन्छ के अर्थको रेडियस लिँदा पनि हुन्छ रेडियस हुन्छ के When an object is thrown upward, it releases. Then it starts falling down towards Earth. It is because of Earth gravitational force exerts on it. Velocity change हुन्छ कि हुँदैन हुन्छ डाइरेक्सन चाहिँ चेन्ज हुँदैन तर के हुन्छ भेलोसिटी चेन्ज हुन्छ जब नजिक हुन्छ ग्राभिटेसनल फोर्स ज्यादा हुन्छ But for objects far from the Earth, acceleration due to gravitational force we can take g to be more or less constant or near the we can take g to be more or less constant on or near the Earth. Far from the Earth, the acceleration due to gravitational force of Earth is given by we should put the value of g, m and r namely universal gravitational constant 6.7 into 10 to the power minus 11 Newton meter square per kg square. This is universal gravitational constant G. 6.7 into 10 to the power minus 11 Newton meter square per kg square. Mass 6 into 10 to the power 24 kg. Mass of Earth. Mass of Earth m equals to 6 into 10 to the power 24 kg. R. Radius of the Earth, that is 6.4 into 10 to the power 6 meter. 9.8 meter per second square. The value of acceleration due to gravity. Why is the weight of an object on the moon one sixth its weight on the earth due to the its g. G is weaker and one sixth of the earth's g. Less or mass less. Mass is less on moon. So it can be 0. Should be measured from the center of the earth. What is the magnitude of gravitational force between earth and 1 kg object on the surface? Weight as Newton. Spring balance, traditional balance. Center of the earth में 0 हो सके. और है motion of object under the influence of gravitational force of the earth. Let us do an activity to understand whether all objects, hollow or solid, big or small. Hollow, solid, big, small, will fall from the height at the same rate. Let us do an activity to understand whether all objects, hollow or solid, big or small, will fall from a height at the same rate. It will. Take a sheet of paper and a stone. Drop them simultaneously from the first floor of a building. Observe whether both of them reaches the ground simultaneously. We see that paper reaches the ground later than the stone. This happened because of the air resistance. The air offers resistance due to friction. The air offers resistance due to friction to the motion of the falling object. Resistance due to friction to the motion of the falling object. The resistance offered by air to the paper is more than the air offers resistance due to friction of the motion object. The resistance offered by air to the paper is more than the resistance offered by the stone. Do the experiment in a glass jar from which air has been sucked out. The paper and the stone would fall at the same rate. Experience it. We know that we know that an object experiences acceleration due to free fall. Equation 10.9. The rate of free fall. This acceleration experienced by an object is independent of its mass. The acceleration experienced by an object is independent of its mass. This means that all objects, hollow or solid, big or small, should fall at the same rate. According to a story, Galileo dropped a different object from the top of the Leaning Tower of Pisa. Pisa, Galileo, in Italy. Leaning Tower of Pisa. To prove the same, as as z is constant near the earth, all the equation k near the earth constant near the earth, g is constant near the earth, as g is constant near the earth, all the equation for the uniformly accelerated motion of an object becomes valid with acceleration a replaced by g. An object is thrown vertically upward. What do you mean by free fall? What do you mean by acceleration due to gravity? An object is thrown vertically upward, rise to a height of 10 meters. Calculate the velocity with which object was thrown upward. Equals to u plus at, where u and v are initial and final velocities, and s is the distance covered in distance covered to be positive when it is in the direction of velocity positive when it is in the direction of the velocity, is positive when it is in the direction of in applying this equation we will take acceleration a to be positive when it is in the direction of the velocity. It is in direction of velocity cha te direction ma direction 70 positive, that is in the direction of motion. The acceleration e will be taken negative when it opposes the motion. Okay, downward g is equals to downward direction now, positive answer, 9.8 meter per second square. Z equals to negative upward in this case upward direction. Applying the CB will take acceleration e to be positive when it is in the direction of the velocity. A is to be positive when it is in the direction of the velocity. It is in the direction of the motion. The acceleration E will be taken negative when it opposes the motion. E is okay. In applying this equation, we will take acceleration E to be positive when it is in the direction of जुन direction मा velocity छ त्यही direction मा के हुनु पर्यो acceleration हुनु पर्यो velocity upward हुन्छ त what the heck it is in the direction of the motion the acceleration is taken to as negative when it opposes the motion ayo hello Shahjad I am fine how about you a car falls off a ledge a car falls off a ledge it is falling down okay हुन्छ न हामीले फ्री फलमा सर्टेन अब्जेक्टलाई जब उकालो जाँदैछ त्यतिखेर यु इज समथिङ समथिङ एउटा पोइन्टमा भीमा पुगेर चाहिँ के हुन्छ जिरो हुन्छ बुझ्यो तर जब माथिबाट झर्छ नि त्यतिखेर चाहिँ के हुन्छ यु इक्वल्स टु जिरो हुन्छ जब फ्री फल हुन्छ त्यतिखेर के हुन्छ भी चाहिँ समथिङ हुन्छ के सो जब फल गर्दैछ भन्दैछ यो कति हुन्छ जी यसको पोजिटिभ हुन्छ a car falls from a ledge and drops to the ground in 0.5 seconds. Let g equals to 10 meter per second square. For simplifying the equation, what is the speed on striking the ground? A car falls off a ledge and drops to the ground. Ground ma jhadda रहेछ. A car falls off a ledge and drops to the ground in 0.5 second. 0.5 second मा तल झर्छ. Trading with CA. Nepali. Yep, I am Nepali. Myself Indian, but I am Nepali since I have that gene. Both of my parents are from Nepal. A car falls off a ledge and drops to the ground in 0.5 seconds. Let G equals to 10 meter per second. For simplifying the calculation, a car falls off a ledge and drops to the ground in time t equals to 0.5 seconds. Let Z equals to positive 10 meter per second square. For simplifying the calculation, okay, what is the speed on striking the ground? V equals to U plus ET. U plus AT. V equals to U plus equals to wind vast U plus that U add. What is the speed on striking the ground? Ground लाई स्ट्राइक गर्दाखेरि कति स्पिड हुन्छ भन्दा सबैले 0 plus Z भनेको 10 into 0.5 V equals to 5 meter per second square हुन्छ 5 meter per second square हुन्छ okay. The next question is what is the speed during 0.5 second? AVERAG average speed TOTL total speed upon total time. Acceleration of a car A positive in this downward in this side. Total speed average speed sum of all the velocity divided by total velocity average speed is total time taken initial velocity plus final velocity 2.5 meter per second square velocity meter per second हुन्छ meter per second average speed meter per second average speed. Okay, how high is the lace from the ground? H निकाल्नु हुँदैछ height. H equals to ut plus half gt square 0 into 10 into 0.5 into 0.5. 2 ones are 2, 2 5s are 10. H equals to 0 plus 5 into 0.5 into 0.5. H equals to 5 into 5 into 5 upon 100. So 5 5s are 25. 25 5s are is equals to 25 into 5. 5 5s are 25 को 5 2 5 5 is 10 11 12 125. 5 1 5 5 2 are 10. 5 2 are 10. 5 3 5 5 is 25 5 are 25. 5 2 are 10. 0 को 0. 5 is 25, 5 4s are 20. H equals to 5 upon 4. 2 2s are 4 1s are 4. 4 1s are 4. Point. 4 2s are 8. 9 10. 4 5s are 20. H equals to 1.25 meter. Half. प्लस में राउंड कर देती हूँ 2.5 ही निकले ना एवरेज ये इनिशियल माइनस फाइनल प्लस इनिशियल प्लस फाइनल डिवाइडेड बाय 2. Average velocity, initial velocity plus final velocity divided by 2. Initial velocity plus final average velocity plus final velocity divided by 2. Now this weight of an object in the mole. Thrust or pressure in fluid. Thrust or pressure and thrust and pressure in fluid, buoyancy, Archimedes principle, relative density. This much. An object is thrown vertically upward and rises to a height of 10 centimeter. An object is thrown vertically upward. U equals to something, okay, yanira x. V equals to 0. An object is thrown vertically upward and rises to a height 10 meter. This is 10 meter. Height 10 meter. Calculate the velocity with which the object was thrown upward. Okay, velocity. V equals to U plus GT. हामीलाई इनिशियल U 0 भन्ने छ U plus G हामीले कति लिनु भनेको छ इट्स नट गिभन 9.8 हामीले टाइम दिएको छ An object is thrown vertically upward and rise to a height 10 meter. हामीलाई S दिएको छ T दिएको छैन. Calculate the velocity with which the object was thrown upward. Calculate the velocity with which the object is thrown upward. The time taken by the object to reach the highest point. Okay. T नभएको. Okay. V square is equals to u square plus 2as. So we don't need this formula. V square equals to u square plus 2 times g into h. V square 0 को square is equals to initial is something plus 2 times 9.8 into 10. Okay, therefore we have 0 को square 0 हुन्छ 0 equals to u square plus 2 into 98. U square plus 98. 2 9s are 2 8s are 16 को 6 1 तो गए 2 9s are 18 19 19 only 10 हुन्छ कति 10 10 काट्यो नि त No, 196. U square is equals to minus 196. अच्छा यहाँ पर मिस्टेक हो गया. V square is equals to U square plus 2 times Z into height. Here we know that object ऊपर जाँदैछ भनेपछि G को भ्यालु के लिनुपर्छ? G equals to जब उकालो जाँदैछ G के हुन्छ? नेगेटिभ हुन्छ. Therefore 9.8 meter per second square हो नि त. V square 0 को square is equals to U square. We have to calculate 2 times G. G minus 10 into height पनि कति छ? 10 छ. height कति छ? 10 छ. Okay, 9.8 लगाउँ न. minus 9.8. Okay. So this is 0 equals to U square plus यसलाई हटायो भने point हटायो भने कति हुन्छ? 98 minus of 196 हुँदैछ. Okay. So यो यतापट्टि जाँदाखेरि यो टर्म के हुन्छ? U square is equals to plus 196 है ना. अगर इसमें मैले 10 लेख्दा 200 हुन्थ्यो. One 196 10 meter 0 9.8 meter per second square. Acceleration of the object upward motion हुँदैछ. V square equals to U square plus 2as. Yep. U square 0 U square 2 into minus 9.8 into 10. So what we have calculated here is minus 2 into 9.8 into 10 to the power 9.8 into 10 meter per second square, which is under root 196 meter per second. Correct. Good job. The velocity with which the object thrown upward. Okay, the time taken by the object to reach the highest point. Four fours are 16 को 6 1 था. 4 ones are 4 5 1 4 4 1 1 1 196. अयो कति छ? 196. long division method 196 पीछे से पेयर करो. 1 1 को स्क्वायर हुन्छ 1 हुन्छ 2 आयो बज्यो. सँगै जोड्छ यो दुईटा. 96 0 21 I don't know. Time taken by the object to reach the highest point. The time taken by the object to reach the highest point. Okay. This h निकालने रहे सामने. v square u square plus v square plus u square. V square is equals to u square plus 2 times g into h. हमले के निकालना है सर. Highest point. An object is thrown vertically upward and rises a height of 10 meters. Calculate the velocity with which the object was thrown upward. The time taken by the object to reach the highest point. Okay, we have to calculate time, not height. The time taken by the object to reach the highest point. Okay, anyways, I have to do it. U equals to 14 meter per second. Okay, v square v equals to u plus 80. v कति छ भन्दा v त 0 हुन्छ. u कति भएको छ 14 plus g 9.8. t we have to find. Okay, t is equals to उक्कालो जाँदा यहाँनिर नेगेटिभ हुन्छ. ओके, u plus यो होल टर्मलाई यता लाँदाखेरि माइनस v equals to u plus 80. 0 equals to 14 plus 9.8 into t. Nine 9.8 into t is equals to 14 हुन्छ. t equals to 14 upon 9.8. 140 upon 98. Okay, 2 4s are 8, 2 9s are 18, 2 7s are 14, 0 को 0, 49. 7 10s are 70, 7 7s are 49. 10 upon 7. 7 1s are 7, 7 1s are 7, 1.7, 8 9 10, 3 na. 7 7 7 14, 7 3 7 4 28, 7 4 28, 29 30. 7 2 14, 7 3 21, 7 2 14, 1.42. 10 divided by 7 1s are 7, 3.07, 4s are 28 minus 2. 0 answer. 7 7 2 7 1 7, 7 2 14, 7 3 21, 7 2 14 minus 10 minus 4 as 10 minus 4 as 6 0 60. 7 7 49, 7 is 56, 7 9 is 63, 7 8 is 56, 4 7 is 56. Okay, this is 1.428 second. 1.428 second. Approximately 1.43 seconds. Okay, anyways, move it. V equals to u plus 80. 0 equals to u1 equal 14 plus 9.8 into t. This is minus 1, so I have to take care of this. 0 equals to 14 plus 9.8 into t. Plus 1. Okay. You can do it. You can do it, bro. You can do it. You can do it. Just believe in yourself. Just believe in yourself. Believe in yourself. You have to believe in yourself. Believe in yourself. Believe in yourself. Just believe in yourself. Okay, I have to memorize something else too. Ayyo. Ammonium. Ammonium. Ammonium hydroxide. Ammonium hydroxide. Nitrate. Nitride. Ammonium hydroxide. Nitrate and nitride. Okay, hydrogen carbonate. Hydrogen carbonate. Ammonium hydroxide and nitrate, nitride, hydrogen carbonate, carbonate, and then sulfite, sulfate, sulfite. Then we have sulfate. Then we have sulfide, sulfite, sulfate, and sulfide. Okay. Then we have phosphate, PHOS, PHAT, phosphate. Ammonium. Is it ammonium? Yes, it is ammonium. NH4 plus, NH4 plus. Hydroxide, OH minus, nitrate, NO3 minus, nitride, N3, not 3, N3 minus, charge 3. Hydrogen carbonate, HCO3 minus, carbonate, CO3 2 minus, sulfite, sulfite, SO3 2 minus, sulfate, SO4 2 minus, sulfide, S2 minus, and then we have phosphate, PO4 3 minus, and then we have again oxide, O2 minus, NH4 plus, ammonium hydroxide, OH minus, NO3 minus, nitrate, nitride, N3 minus, nitride, N3 minus, hydrogen carbonate, HCO3 minus, carbonate, CO3 2 minus, sulfide, SO2 minus, sulfite, SO3 2 minus, SO3 2 minus. Okay, sulfate, SO4 2 minus, phosphate, PO4 3 minus, oxide, O2 minus, and sulfide is S2 minus. Okay, iodide, okay, hydride, HYDRID, hydride, H minus, hydrogen, H plus, hydride, chloride, Cl minus, bromide, Br minus, iodide, I minus. Okay, oxide and sulfide, magnesium 2 plus, calcium 2 plus, zinc 2 plus, Fe2 plus, Cu2 plus, Al3 plus, Fe3 plus. Na plus, K plus, Ag plus, Cu plus. Hydrogen chloride, hydrogen sulfide. Where is, I have to take a picture of that. Hydrogen chloride, hydrogen sulfide, carbon tetrachloride, magnesium chloride. Then we have aluminium oxide, calcium oxide, sodium nitrate, calcium hydroxide, sodium carbonate, and then we have ammonium sulfate. Sodium oxide, aluminium chloride, sodium sulfide, magnesium hydroxide. I think I have to leave. I have a class from 10:30, so it's already 10:22. So I'll leave, okay? I have to go since I have a class. Now only God can save me from this barium chloride. It is barium, BaCl2. Light is also gone. Bye bye everyone. I have to go. I have a class.